Welcome to Mr. Leek's free science tutorials. This question, right, is the starting of the forces topic. When you get into year 10, 11, then the forces topic is much larger. However, this is a very good introduction to the topic. The question we're going to be looking at is name 8 forces and state whether they are contact or non-contact forces. So the key to this is 8. Contact and non-contact. Now the wording themselves makes it reasonably clear what they're actually talking about. The definition is a contact force has interactions between objects that touch, right? So obviously if you've got a contact sport like rugby, then there's obviously interaction between the different players in rugby. A non-contact force, I guess a bit like basketball. Theoretically, basketball should have very little contact, where attract or repel even from a distance. So contact force is where there is a physical touch. Non-contact force is where there is some form of attraction or repulsion, right, that can even be from a distance. Now, the 5 contact forces that you need to remember. An applied force is something like baseball, where it's a physical force that is then put into an object itself, which is an applied force. A spring force is then where a spring is then compressed and it's giving out a force in the opposite direction. Drag force is a bit like a parachute, right, where the force going upwards is then a drag force. I can always remember as a kid putting my arm out of the window when my dad was driving on the motorway and putting my hand out, and that was like a drag force. Frictional force. Frictional force is then the contact force between 2 different objects. Friction between your hands, rub your hands together. There's a frictional force in between the 2. And then the normal force is basically one at 90 degrees, like putting something on a table, where there's a force up, there's a force down. That's your normal force. The 3 non-contact forces that you need to remember are magnetic force, right? So I could put a magnet underneath the table I'm talking about at the moment and I can move something around on the top of it, right? The magnetic force is a non-contact force. Electric force is a bit like static. And gravitational force, okay, we're all aware of it, but when something falls out of a tree or falls out of the sky, you can't see the force, there is no contact for it, and that is then gravitational force. So the question was, name 8 forces and state whether they are contact or non-contact forces. So I would say a contact force has interactions between objects that touch. Examples are applied force, a spring force, drag force, frictional force, normal force. A non-contact force, where things are either attracted or repelled, are magnetic force, electric force, and a gravitational force. That then answers the question, name 8 forces and state whether they are contact or non-contact forces. Welcome to Mr. Leek's free science tutorials. Now this question, right, what I've done is I've really designed this question just to make you learn certain things. You're never going to get a question in a GCSE exam that says name 7 ways of measuring in physics and what are their units. You're not going to get a question like that. What you're going to do is you're going to get a question that says the whatever is 17 meters squared. You then need to be aware that they are then talking about area. Or the object is 7 newtons. You need to be aware that they're talking about weight. So what you need to be able to do is you need to be able to list off all these different measurements, and with them you also need to be able to give the units. And vice versa to that, you need to be able to say the units and say what they're measured in. Now, there is a huge number of other ones of these that you're going to need to know about eventually. So, area. You'll do it in maths, meters squared. Okay, it could be centimetres squared, but generally in this it is meters squared. Weight is measured in newtons. Weight is a force. Force is also measured in newtons. So if ever you see anything that is measured in newtons, it is always a force. Mass, measured in kilograms. My go-to weight is a bag of sugar. A bag of sugar is 1 kilogram. So if you want to associate anything, if you want to work out the weight of any, or the mass of anything, using the wrong terminology there, if you want to use the mass of anything, relate it to how many bags of sugar you think it might be, and that'll give you an idea about how many kilograms it is. Gravitational field strength is the number of newtons per kilogram. Right, and that little line there is basically the same as divide. Right, so it's newtons divided by kilograms. Newtons per kilogram. It's the number of newtons every kilogram. Force we mentioned before. Work done is measured in joules. Anything that ever has joules next to it is always to do with energy. So I know that work done is something to do with energy. It's the amount of energy used to make something happen. Again, an easy one. Distance is measured in meters. The vice versa of that should be, if I say to you, something is 7 meters squared, you should be able to say to me, that's area. 15 newtons, and you would be able to say to me, that is weight or force. Oh, that car over there is 1,000 kilograms. That is, its mass. Oh, this thing here has a 17 newtons per kilogram, right? And then what you do is you could say that's gravitational field strength. We talked about newtons before. 75 joules, that's energy. And from this, you could work out that that's work done. That car over there is 17 meters from me. You know, that is then its distance. So really, this question, right, isn't really a question. It's you've got to be aware of the different ways of measuring things and the units that go with them. Units are absolutely vital to understand and know what they are. Welcome to Mr. Leek's free science tutorials. Now, this is a very, very, very common question that is asked throughout science, throughout physics and forces. Possibly not actually asked directly on an exam paper, however, there are ways in which it's implied. And it's one of those misconceptions. Even in the previous video, when I was talking about mass and weight, I actually used the wrong word and I had to correct myself during the video. The question is, what is the difference between mass and weight, and how can they be calculated? Quite often you go to the supermarket and what you'll do is you'll say, what's the weight of that bag of potatoes? You would say, what's the weight of that bag of potatoes? And it would say 25 kilograms on it. That is actually wrong from a science point of view. So what I'm going to do is I'm going to go through what mass is, what weight is, and then the formula to calculate them. Now, weight. Weight is a force, mass is how much matter. So weight is the force acting upon an object due to gravity, and it's measured in newtons. Mass is how much matter it's made of, and it's measured in kilograms. Best example is thinking about me, right? I'm going to make up these numbers here. I don't know my weight and my mass at this moment in time. But let's say I weigh 100 kilograms. Now, what I've done is I've just done that wrong. I don't weigh 100 kilograms because weight is measured in newtons. My mass is 100 kilograms. And that 100 kilograms basically says how many particles, how much matter I am actually made up of. Right, so stood here doing this video, I am 100 kilograms, and that is exactly how many particles I am. If I am lucky enough, right, and I go on holiday to the moon, right, I then go to the moon, and the question that I'll ask is, what's my mass on the moon? Right, and people will come up with all sorts of different answers. But what you've got to do is you've got to think about what's happened to my matter. When I go to the moon, my matter hasn't changed. It is still 100 kilograms because the particles that make up me are exactly the same. Nothing has happened, so my mass, wherever I go, always stays the same because it's the number of particles. Weight is the force acting upon an object due to gravity. So let's say in this room where I'm doing this video, my weight is 1,000 newtons. Right, so that is the force that I am applying down into the ground. That's the force on the floor. I then go to a planet somewhere in the solar system, and the gravity is half of what it is on planet Earth. What is my force applied this time? If the gravity is a half, right, then my force acting down will also be a half. So my weight on this planet with a gravity of a half is then 500 newtons. What's my mass? Stays the same, doesn't change. If I go to the planet, 57 light years away from here, right, and the gravity on that planet is 10 times that of Earth, my weight on that planet will then be 1,000 times 10, which is then 10,000 newtons. That's the force that I am now applying to the ground. My mass will be 100 kilograms, hasn't changed. Now, the way that you actually work these out, and you have to do maybe sometimes a bit of jiggery-pokery with the actual equation itself, weight equals mass times gravitational field strength. You need and must remember that equation, right? I would bet that there is going to be an equation or a sum on your GCSE exam that goes along with that equation. Weight equals mass times gravitational field strength. Now, what you need to do is you need to be able to move this equation around a little bit. Weight equals mass times gravitational field strength. Just a little brief bit of maths. If I want to work out the mass, what I do is that's times, so I divide it on the other side. So mass would equal weight divided by gravitational field strength. Now, gravitational field strength is for Earth a fixed unit or a fixed value. It is the gravity exerted around an object, and on Earth, vast majority of the time, it is 9.8 newtons per kilogram, and that stays the same pretty much where you are at sea level. If you go higher, above sea level, say to the top of Mount Everest, it will reduce. If you go to the bottom of the deepest ocean, it will get bigger. Sometimes they will say it is 10 newtons per kilogram, but vast majority of the time, it'll be 9.8 newtons per kilogram. Now, back to the question. The question is, what is the difference between mass and weight, and how can they be calculated? Mass is how much matter an object is made of and is measured in kilograms. Weight is the force acting upon an object due to gravity and is measured in newtons. How can they be calculated? Using the equation weight equals mass times gravitational field strength. Good practice is also to write the units after each bit. Weight in newtons, mass in kilograms, gravitational field strength in newtons per kilogram. Welcome to Mr. Leek's Free Science Tutorials. This topic, right, or this question, what does Hooke's law state, and describe the experiment used to investigate Hooke's law? Now, for the purposes of this video, what I'm going to do is I'm going to go into it quite briefly, because a later video will go into a lot more detail as it's a required practical and a lot of detail is then required. But this video is basically an introduction to it. Now, what does Hooke's law state? Hooke's law says that the extension of an elastic object is directly proportional to the force applied to it. Now, that sounds absolutely crazy complicated. Now, basically what it means is, if the force applied is doubled, so if you've got a spring and you apply 10 grams to it, if you then double the force, it doubles the extension. Right, so that is then, Hooke's law says the extension of an elastic object is directly proportional to the force applied to it. If the force applied is doubled, the extension doubles. If no force is applied, there is no extension. So you've got your spring, you hang 10 grams on it. And what you can do is you can work out how much is extended going from no grams to 10 grams. If you then add another 10 grams, the force, based on Hooke's law, the extension should double. Okay, so that's what Hooke's law is then saying. Now, for the purpose of your exam, what you need to do is you need to talk about this definition, not this definition. Because you need to use all the correct terminology, which is extension of elastic object is directly proportional to the force applied to it. These directionally proportional are the words that are then going to get you the best marks. Now, the actual method itself, right, what I'm going to do is I'm just going to double quickly just go through it. Set up the apparatus as shown in the diagram. Add 10 gram mass to the holder and record the spring's length. Okay, using your ruler down the side here, record the spring length. Add another 10 gram mass and record the new spring length. Take away the previous spring length from the new length and calculate the extension as the difference. Repeat by adding 10 grams until 100 grams is reached. So, in a nutshell, you start off with no weights on, you add 10, record the extension, 20, 30, 40, all the way down to 100. And what you'll eventually do is then you'll plot that on a graph and you should see an approximate straight line, right, until Hooke's law then stops of being applied, which is then where we're talking about that in the required practical. So, the question that you need to answer: what does Hooke's law state, and describe the experiment used to investigate Hooke's law? So, Hooke's law states that the extension of an elastic object is directly proportional to the force applied to it. Describe the experiment. Add 10 gram mass to the holder and record the spring length. Add another 10 gram mass and record the new spring length. Take away the previous spring length from the new length to calculate the extension. Repeat by adding 10 gram masses until 100 grams is reached. Right? That then answers that question. What does Hooke's law state, and describe the experiment used to investigate Hooke's law?